Hello all. So in this video, we'll talk about set of actual questions, right, on this topic, regression, right. So we'll cover all three: simple regression, multiple regression, as well as you know um, non-linear regression, right. This will give you, fair idea that in last couple of years. So I think we have taken 2022, 23, and 24. These questions papers are curated from your actual exams across 22, 23, and 24. And we have just actually kind of organized it around MCQs and your long answers. So let's look at the first question, right? I'll just read it with you. What term is used to describe regression method that have a linear function relationship between dependent and independent variable? So no brainer, right? That's the linear regression models or simple linear regression models, right? State true or false. Linear regression is more flexible than non-linear regression. Right? Think through it, right? There is actually more constant on linear regression, right? It can only model linear relationship between independent and dependent variables, while non-linear can map more complex, right, relationship. So this is actually false. You have been given an example, and you might remember your best fit, right? And they are asking the same thing, right? What do the vertical lines 1, 2, 3, and 4 represent? So your line of best fit is this straight line that you are having, longer straight line, right? And your observed values are the different data points that you have, error or residuals, right? That's what that actually these vertical lines are talking about. RSME, is something that when you compute it and take the squared mean squared error on that, right? There is a typo also. It shouldn't be RSME, it should be root mean square error, right? RMSE. These are more involved. So there is a table where you have 3 entry in each row, and you have been asked to match them. So root mean square error, mean absolute error, and linear regression, right? So what is root mean square error, right? Root mean square error is the square root of variance of residuals, right? So A3, wherever you see A3, that is just option B, right? Now, just for the sake of saying, MAE, average magnitude of error, so B to 2, and linear regression is predicting the value of dependent variable on the basis of independent variable, right? So option B here. In linear regression, the graph of the relationship between the dependent and independent variable follows an equation that represents a what? A straight line, right? Because parabola will be non-linear. Linear equation is not right? So because basically it is talking about what kind of line it is not. So this is a very close answer C, right? And curve, no, it is not curve, right? So we'll go for answer A. What can be used to find the effect of age, weight, and height on cholesterol level in your body, right? So this could also be a practical example that we are talking some time back, right? You can use multiple linear regression, right? You can assume that relationship is linear, and you can actually use it to figure this out. You might ask, right? So why not correlation? Because this is not about finding correlation. Why not linear, simple linear regression or simple linear regression? Because there are more than one variable. Non-linear regression, right? Because we are making an assumption that somehow age, weight, and height can actually give you, right? It shouldn't be that if your age goes from 50 to 60, your cholesterol goes by say 100 or something, right? So there's you can assume that relationship is linear, and multiple linear regression will be the best answer here, option D. So these are the typical MCQs. As you might have seen, they are repeating. As long as you keep some of the common terms, you can easily answer them. Explain the significance of the root mean square error in linear regression. How does a smaller RMSE value reflect the quality of a regression model, right? So what is the significance of RMSE? It helps you, find out a spread, right, of your residuals, right, from the best fit. And as you know, a smaller RMSE is always a better quality of a fit in the regression model. You can also look at the notes. I'll share these talks, right, in the same channel, so you can actually scroll through it. You can scroll through your books, whatever you are reading, and you can actually take some example, explain how you compute root mean square error, and then talk about that how it helps you find out best fit, right? So the way you find your best fit for linear regression is guided through root mean square error. Define multiple linear regression. Write and explain the formula of multiple linear regression. So at this place, right, you can go back. How you define multiple linear regression? When you have more than one independent variable that actually helps explain your outcome or dependent variable, and relationship is linear, right? So in that case, multiple linear regression is a kind of modeling technique that helps you explain that through a set of modeling process, right? Formula for it, you might have remembered, right? Your y is beta 0 plus beta 1 x1 plus beta 2 x2 plus dot 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 beta and xn, and then an error term. And so here you can explain each of those individual xi's and their corresponding betas, and then you can explain residuals of psilon, as well as your intercept term beta 0 in some way, right? I think that should be good enough for 200 words. Regression method that do not have a linear function, what we call them? Non-linear regression models. Exponential regression model and polynomial regression models are example of non-linear regression model. So this could be a relatively tougher question for 1 mark, right? So you need to know that exponential and polynomial, as well as actually you have logarithmic, many others, right? Those are a form of non-linear regression, right? So your option should be B here. Why is the primary characteristic of what is multiple linear regression? So it uses only one independent variable to predict the outcome of a dependent variable? No. It uses multiple dependent variable to predict the outcome of an independent variable? No. It uses multiple. What is the difference here? It uses multiple independent variables, right, to predict the outcome of a dependent variable. Option C. Okay. I'm not reading through option D because it's totally, totally unrelated. This is saying this diagram below, right? So then a scatter plot of two variables. Linear regression helps us find out the line here, right? What you call it? The line of best fit, right? It's not trend line, it's not regression line, it's not correlation line, it's line of best fit. In real life scenario, why is it typically best to have a small root mean square error value in regression models, right? So let's read through the option. A small RMS indicates higher mean absolute error. No. So typically, what happens is you are going to have higher RMSE than MAE, and that anyway, is not related. A small RMSE indicates a stronger linear relationship between dependent and dependent variable. Let us hold on this. A small RMSE signifies higher accuracy of the model prediction. Yes, right. Lower the RMSE, higher the accuracy of the predictions, right? A small RMSE suggests that the model needs to be retrained. No. If it was actually a big RMSE, then your fitment has been poor, and that would have actually might have asked you to retrain. Consider the following equation for simple linear regression. Yes, y is equal to mx plus b. So there are common variations around it, right? Beta 0 x1 plus beta 0 plus beta 1 x1, or y is equal to mx plus b. Make yourself comfortable. This could be asked in one of these forms. Which of the following is correct with respect to the given equation? Y is an independent variable, x is a dependent variable. Yes. Y is an intercept and x is no. What is intercept here? B. X is an intercept? No. What is intercept here? B. Y is a dependent variable, x is an independent variable. Yes. Y is dependent, x is independent. Right? The below mentioned formula represents beta 0, beta 1, x1, beta 2, x2, beta 3, xp, xi, beta 3, x3, beta p, xip, and epsilon, right? Epsilon I. where I is equal to 1 to n, right, for each observation. So yeah, this is what multiple linear regression, right? No point for guessing it. Describe the purpose of MAE. So again, right, mean absolute error, is used to find the best fit, right? And this helps you find it out, right? Some idea that how far your residuals are, right, from your best fit line. And then from there on, it's pretty similar to RMSE, and you correctly keep describing that. Salma started a business 10 months back. It is observed that her income has increased exponentially every month. Which type of regression can we relate this to? So, Sarma is actually, joining last 10 months. Every month her income. So, income is your, dependent variable, month after month, right? So, that is your independent variable. Every change in month, actually her income is exponentially rising. So relationship is not linear. So what type of regression can relate to? Simple linear regression, right? What could be formula for it? And no, sorry, which kind of regression can you relate to? Non-linear, regression. Write the formula, and explain the terms used. So how you'll describe, say y is your salary, right? So your salary is going to be some initial number, say b0, and then you multiply it by exponential of your month, right? So you can have your salary y is equal to some intercept term a0, b0, and then exponential of this month, right? What is the shape of graph formed in this case? What will be the shape of graph? It will be rising continuously, right, at a non-linear level, right? So we have actually kind of, you can see, right, a power bx, then you can describe the word. Steps, what you can do here, if you take, logarithmic of y, then what happens? Log of a and plus log bx into ln e, right? So what it gets translated into? Ln a plus b into x of ln y, right? So then you can actually sort of convert it into a linear regression from here on, and then you can fit them out. We talked about graph, right? What is going to be exponential in nature, right? Okay. A square root of variance of the model, what it is that? If you take a square root, then root mean a square error, or root mean a square deviation, whatever you want to call it, right? So option A. In which type of learning do lessons act on data without human intervention? Unsupervised. Y is equal to mx is the formula for simple linear regression. State whether the following statement is true. For formula for non-linear regression is same. No. Right? Formula for non-linear will have some exponential, logarithmic, polynomial term, while linear one will be simply having variation of y is equal to mx plus b. If regression trees are used when the dependent variable is non-continuous, it is given a statement true or false. Regression trees are used. So if it is non-continuous, then it will be decision tree. We'll talk about this is related to classification as well. The actual value of what depends on the data and accuracy required, right? So yeah, actual value of root mean square, right? Trigonometric function, example of linear function, right? No, trigonometric function will not be linear. So this covers actually all your MCQs and other question across 3 years. You can expect similar 1 marks, 2 marks, and 4 marks question that we saw, and as long as you cover your theory well, I think you can answer many of these questions correctly and with good confidence. So thanks for the exam. Do explore, try and take some small data set, run through at least simple linear, multiple linear regression model fit, try and find out R square, goodness of fit, and some of those things, play around. That will help you recall things in your theory exam as well. So we have covered actually, we had actually 3 videos around regression. We talked about simple linear regression, then multiple and non-linear regression, and then we reviewed the questions for you. We'll actually meet again on next video, which will be about classification, and we'll take decision trees as well as another version that we call k nearest neighbor. Those are again actually frequently tested from your exam perspective. So do subscribe to this channel and look forward to the next videos. Thank you.